The objective of this lesson is to introduce you to the Arduino integrated development environment and help you set it up for the project. By the end of this lesson, you will be familiar with the key features of the Arduino IDE, how to manage boards, and how to prepare it for future programming tasks. Now, what is the Arduino IDE? The Arduino IDE is a powerful, user-friendly software that allows you to write, compile, and upload code to different microcontroller boards, such as the ESP and the Arduino Uno. It has become the go-to platform for anyone looking to develop embedded systems or work on IoT projects. Some of its key features are syntax highlighting, a wide range of built-in libraries for hardware interaction, a serial monitor for real-time data collection from the board. Now let's go over the steps on how to install the Arduino IDE. First, you're going to go to the Arduino official website. Once on the Arduino website, you're going to go over to the software tab. Once here, you're going to choose the suitable version for your operating system. Remember to also install the needed drivers for the COM ports if you don't have them already installed. You will be greeted by a clean, minimal text editor in the middle, with a toolbar at the top and a status window at the bottom. This is where you will write your code, also known as sketches. But before we dive into programming, it is essential that we get familiar with some of the Arduino IDE's core features. This is the main area of the IDE, the code editor. Here is where you will write your sketches. It includes features such as syntax highlighting and autocomplete for common commands, making it easier to write error-free code. Then we have the toolbar at the top. There is a verify icon which compiles your code and checks it for errors. There is an upload button that sends the compiled code to your selected board. There's of course debug, but we don't have a board selected right now. And of course the board selection. We also have the serial monitor on the right. This opens up a window in which it displays real-time data from the board. The serial monitor is a useful tool for testing and debugging. It allows you to receive real-time data from your microcontroller, like sensor data or error messages. It also allows you to send commands to your microcontroller. Arduino has a vast collection of libraries that allow you to interact with sensors, display, and other hardware. You can access the libraries by clicking this icon on the side or by going to Tools and Manage Libraries. The Arduino IDE is compatible with a wide variety of microcontroller boards. To start coding, you will need to configure the IDE to the specific board that you will use. Since we will be working with the TTGO T-Display ESP32, this is the board that we will be setting up in this tutorial. The latest version of the Arduino IDE can automatically detect connected boards. Simply plug in your board using a USB cable and the IDE should recognize it automatically. I will be doing that now. Once I have connected the TTGO via USB to the laptop, I can see that it shows up in the board selection. While my board might be available for a connection, the IDE does not have the required libraries to run code on it, due to it being an ESP. So now we will install the required library to run the ESP32. Simply go over to the board's icon and search for ESP32. Then we will be installing the first option. When a board is connected, you will also see a notification at the bottom of the IDE. This will show the board name and the corresponding communication port. For Windows, it can be, for example, COM3, and for Mac, it could be slab USB to UART. Now that the Arduino IDE is configured, it's time to write your first sketch to test that everything is working properly. This initial sketch will simply print a message on the serial monitor. This will ensure that your IDE is correctly communicating with the board. After the ESP32 board library has been installed, we are ready to start writing the code. Simply go to File, New, and create a new sketch. So as we can see, when we create a new sketch, we already have the preset setup function and the loop function. In the setup function, we will only write code once, and this will initialize it. And in the loop function, it will repeat it on a preset interval of time. We're going to start by writing what we are going to do. In order to create a comment, we're going to put 2 forward slashes. All of the text after these 2 forward slashes is only text for the documentation. So we're going to start by initializing the serial monitor. This is done by using the serial.begin function. And we're going to be setting it to a baud rate of 115/200 because that is the speed at which the ESP32 functions. Remember to always put a semicolon at the end of every syntax. You will get an error if you don't. Now that we have initialized the serial monitor, it is time to display the message. This will be done using the serial.print function. We will be adding ln at the end of the function to show that we want a new line. Then of course we will be inputting the needed text. This will be done in quotation marks. This is done due to the fact that every piece of text needs to be saved as a string, and to save it as a string, it needs to be in quotation marks. Great! Don't forget to add the semicolon, and we are ready to verify the code. Now let's verify our sketch and see if it works or if it has any bugs. Oh, and it looks like it compiled successfully, so now let's go on and upload it to the board. The sketch is being verified and compiled again, and then sent to the board. All of this information can be seen in the status window at the bottom. Once you see the reset message, it means that the code has been uploaded successfully. Let's go over to the serial monitor and see what output we get. We will of course have to change the baud rate to the one that we initialized at the beginning of the code. Now we can see that nothing is being displayed, but if you click the reset button on the side of the ESP board, all of the messages will appear. And there you have it. It's printed out correctly, which means that the connection is successful on both ends. Now that we are done with this lesson, your process might not have been so streamlined as mine. So we're going to be going over some troubleshooting and some common issues. If the board is not detected, ensure that the USB cable is connected properly and the cable supports data transfer. Some cables are charge only. And if the code fails to upload, double check that the correct board and port are used. Restart the Arduino IDE and re-upload the code. And of course, make sure that the microcontroller is getting enough power. That is, if you're powering it via a USB port on your laptop or computer. So congratulations, you have written your first piece of code. In this lesson, we introduced the Arduino IDE and went over its key features. We walked through the steps of setting up and configuring the IDE for microcontroller programming. We also wrote a simple sketch to print out a message to the serial monitor. This helped us ensure that there was a correct connection between the board and the IDE. This foundational knowledge of the Arduino IDE will be crucial as we move forward in the course. We will be writing more complex code and interact with hardware. In the next lesson, we will focus on importing and managing the Arduino libraries to extend its capabilities.